Okay, here we go. Last group of quadrilaterals. We're going to discuss trapezoids and kites today. What is a trapezoid? Most of you are familiar with this figure and know that it is a trapezoid. But based on the definitions that we've been using, how can we define a trapezoid? It's a quadrilateral, because it has 4 sides, with exactly or only one pair of parallel sides. So here's my parallel sides. These two opposite sides are not parallel. So would we call this a parallelogram? No, because we only have one pair of opposite sides that are parallel. We call that pair of parallel sides bases. And then the other two sides are called legs. So these are our bases, these are our legs. 2 of each. Okay? Know those terms. We use different words to refer to different parts, so you need to make sure you're using them correctly. And when I say base, you need to know what I'm talking about. When I say leg, you need to know what I'm talking about. We have a special kind of trapezoid called the isosceles trapezoid. Now let's build on what we already know. What was an isosceles triangle? Hopefully you remembered it was a triangle that had 2 congruent sides. So what do you think an isosceles trapezoid is going to be? It's going to have 2 congruent legs. Okay, so try to relate things to what you already know. So here's our trapezoid. Okay, remember they can be oriented any way. Our 2 legs are marked congruent, therefore this is considered an isosceles trapezoid. And that creates some new relationships. If you have an isosceles trapezoid, then the base angles, which are these angles that come off the base, these are going to be congruent to each other. Both pair are. Okay, so these up here are going to be congruent as well. Now, the 2 pair are not congruent to each other, but the 2 in the pair are congruent to each other. And the diagonals of an isosceles trapezoid are congruent. So this whole line BD and this whole line AC are congruent to each other. They do not bisect. Okay, don't start throwing in properties of other quadrilaterals in here. They do not bisect each other, but they are congruent. Okay, notice that we end up with a couple of congruent triangles here. Okay, why do we know that these 2 triangles are congruent? Okay, think about that. See if you can figure that one out. Another part of a trapezoid is the median. Again, we've learned that word before. It almost always means middle. We have a median in the middle of the road. We had a median that extended from a vertex to the middle of the opposite side in a triangle. The median of a trapezoid is the segment that joins the midpoints of its legs. So again, a lot of times when you just hear the words, it's kind of meaningless. So put those words into a picture. We have a trapezoid. It's going to join the midpoints. Okay, midpoint means middle of the legs. You have to know which ones are the legs. Okay, so here's the middle. How do I know it's the middle? Well, because the 2 parts are congruent. Okay, so now if I join those 2 midpoints, I get what's called the median. Sometimes you'll hear it called the mid-segment. Means the same thing. Well, we have a theorem that deals with that median, and it says that the median is parallel to the base, so we end up with parallel lines cut by transversals. And then its measure is 1/2 the sum of the bases. Sum means we're doing what? Adding. So we have a formula that looks like this. The median can be determined by adding the two bases and then dividing by 2. It's like taking the average. Okay, we're adding it and dividing by 2. It's halfway in between the two. So if I had something like this, I told you this was 8 and this one was 10. What is the median? Well, it's halfway in between the two. So you could just figure it out. Mental math is 9 because that's halfway in between, or you could follow the formula. 10 plus 8 divided by 2 is 18 divided by 2. And you get 9. Either way works. Okay, it's the average, it's the midway. Okay, so let's do this. We know that DEFG is an isosceles trapezoid with the median or mid-segment MN. So that already tells us that these segments are congruent to each other. Find angle 1, 2, 3, and 4. If the measure of angle 1 is 3x plus 5 and the measure of angle 3 is 6x minus 5. Okay. So what is the relationship between angle 1 and angle 3? Again, we have parallel lines being cut by a transversal. These are same side or consecutive interior angles. You really should know by now, automatically, instinctively, that those two angles are supplementary. What does that mean? It means that if we add them up, they will equal 180 degrees. Now we do the math. We combine our like terms. Our 5's actually cancel out. So x equals 20. Does that answer our question? Our question said to find the measure of angle 1, 2, 3, and 4. Well, in order to find the measure of angle 1, I've got to plug that 20 in to the 3x plus 5. So that's 3 times 20. Remember, we got to do that first, so we get 65. So if the measure of angle 1 is 65, the measure of angle 2 has to be 65 because these are base angles. This is an isosceles trapezoid and they are congruent to each other. Now there's two ways we could figure out angle 3. Can you think of those two different ways? Okay, here's one way. I know that angle 3 is 6x minus 5, so I can plug in that 20 that we found for x down here. Remember to do your multiplication first. PEMDAS. It's 120 minus 5 is 115. I also could have used my supplementary relationship here. I knew that they had to add up to 180. Well, if angle 1 was 65, what is angle 3 going to be? When I subtract, I get 115. As long as your relationships are true and your math is sound, you will get the same answer either way. So again, I've said this many times now, go with the relationship that you understand best and that you feel most comfortable with, the one that immediately pops into your mind. Since angle 3 is 115, then angle 4 has to be 115. What should these four angles all add up to be? If this is a quadrilateral, they should add up to be 360 degrees. And you can check yourself there just to make sure you're not making any careless mistakes. Here's another one. Again, remember our trapezoids can be oriented any way. We determine the bases by looking for the parallel lines. They tell us this time that JK is 18, WZ is 25. They want us to find out the smallest side. Okay, so again, let's use some common sense. We know that this side is the shortest, so it has to be less than 18. So we could go through a formula or we can think it through. If 18 is halfway between these two, how much did we add to 18 to get to 25? We added 7. So we got to add 7 to something over here to make 18. What is that something? 11. Or we could have used our formula, base 1 plus base 2 divided by 2 equals our median, and plugged in the parts that we know. We don't know base 1, that's our small one. Base 2 is 25, divided by 2 is going to equal 18. How do I get rid of this 2 on the bottom of my fraction? I've got to multiply by that 2, and I have to do it to both sides of my equal sign. These 2's cancel out. So I have x plus 25 equals 36. When I subtract the 25, x equals 11. Again, two different approaches, but because they're both mathematically sound, they both are using true relationships, I will get the same answer either way. Go with the one that makes the most sense to you. Okay, again, we have a trapezoid. We know that angle 2 is 43, and angle 3 is we don't know. How are we going to find it? Think about it. Think about it. What do we know in an isosceles trapezoid? We know that base angles are congruent, so that means angle 1 is 43. Now, because we have two parallel lines being cut by a transversal, here we have consecutive or same side interior angles that are supplementary. So what is my missing number going to be? What can I add to 43 to make 180? D, 137. All right, so that's it for trapezoid. Know what makes a trapezoid, know its parts, and know the relationships within. Our last quadrilateral, I know you're really sad, is the kite. Definition for a kite is a quadrilateral, meaning it has 4 sides. It has 2 pairs of consecutive congruent sides. Consecutive congruent sides, not opposite. This is not a parallelogram. This is not a rhombus. I have lots of people wanting to label a rhombus a kite. Okay, notice the 2 consecutive sides. They're one right after another. They touch each other. Those are the ones that are congruent. Okay, then down here, they're touching each other. Those are the ones that are congruent, not our opposite sides. Okay, don't get them mixed up with the rhombus. What else do we know about kite? What are some properties that it has? Its diagonals are perpendicular. Okay, that was true of a rhombus as well. So again, don't get them mixed up. They are different. You need to know the differences. A kite has exactly, which means only, 1 pair of opposite angles that are congruent. So what does this look like? Okay, here's my kite. I have consecutive sides that are congruent. 2 pair. They are not all congruent to each other. Notice these are longer. We have diagonals that are what to each other? Perpendicular. Here comes my little red one. Okay. And then they have only one pair of opposite angles that are congruent. Okay, these two are congruent. These two are not. So I'm not going to put congruency marks in there. So know all of these relationships in a kite and be able to use them. So here's the breakdown. If I did a Venn diagram of quadrilaterals, it would look something like this. We have four-sided objects called quadrilaterals, some of which are I'll get it here in a minute, parallelograms. Okay, remember what a parallelogram was? Two pairs of opposite sides that are parallel. Then we have some parallelograms that are even more special that we call a rhombus, where not only are the two pair of opposite sides parallel, but they are congruent to each other. So here's our parallelogram, like something like this. But on a rhombus, they were all the same size. They're all congruent to each other. Some parallelograms are rectangles, where they have different length sides, opposite sides, but everything, all the angles were right angles. Then our rhombus and our rectangle overlapped to form a figure where all four sides are the same and all four angles are right angles. What was that called? A square. It's getting messy in there. Then we had some four-sided objects that were not parallelograms. They did not have two pair of parallel sides. One of those is the kite, which we just learned doesn't have any parallel sides. None of those are parallel. And then we had the trapezoid. How many parallel sides does a trapezoid have? One pair. And then we had a special kind of trapezoid where those two non-parallel sides were congruent, and we call that an isosceles trapezoid. So this is what a Venn diagram would look like, classifying quadrilaterals. Or you can have a tree diagram that would look like such. We start off with quadrilaterals. Again, we have different kinds of quadrilaterals. We have the parallelogram, the kite, and the trapezoid. Parallelograms can be broken down into two different kinds, the rhombus and the rectangle. Congruent sides, but not congruent angles. Congruent angles, but not congruent sides. Then we could create a figure that has both congruent sides and congruent angles, and we call that the square. There are no special kinds of kites, but we had one kind of special kind of trapezoid, and that was the isosceles trapezoid. So if you understand how these things are related to each other, that might help you keep track of which ones have what properties. Anything under quadrilateral is going to have the properties of a quadrilateral. Anything under parallelogram is going to have the properties of a parallelogram, and so on.